seems there's still a few people who haven't yet finished. I'll give a little bit longer, then look at the solution and talk through the solution of this challenge. Okay, so looking at this challenge is looking at seeing how many unique sites there are, and this builds on what we did before. So just before the lunch, we were looking at how many unique species are there in the data, in all of the data. And we can basically use the same approach. So we use this unique built-in function, Pandas function, to return a canonical list of all the unique plot IDs, i.e. all the unique geographical locations that are in the data frame that contains all the data from the survey's CSV file. Now, so that lists that gives the list itself, or I say list, but it's actually, as we saw before, it's actually a NumPy array. So we can do a similar check for plot ID as we did before, and we see again that what that returns is actually a NumPy array, and what it looks like. Oops. What it looks like is yes. As follows. Now, then the question, how many unique species are there, is just the length, or how many unique sites there are, is just the length of that array. So we could have, we use the length function, or we could actually get so this is a NumPy array, and NumPy arrays also have this attribute of shape. So we could also just look at the attribute of shape, which tells us number of rows, which is number of unique site entries. The answer for number of species is the same, really, using the same approach. Again, we can use length or shape. Then there's a question about what is the difference between taking the length of that NumPy array, or alternatively, using this newly introduced built-in method called nUnique. So what that apparently does is that for a given, so we know that querying the data for this plot ID label gives us out what was it? It was a type, it was a series, Pandas series. So apparently there is a built-in method for Pandas series called nUnique. I add a question mark, not because it says in the notes there, but because I want to see what the guidance says on that. So that's of course because I see pd.unique. No, sorry. pd.series.nUnique. Okay. There we go. Sometimes the documentation or sometimes the question mark doesn't necessarily work, but sometimes you need to use help. And this would have worked if I used help, called that on the actual instance that we're looking at now. It should have also worked. Should also work. Let's see if I do help on Pandas, which I've renamed, abbreviated as PD, series. Let's see if that works. Oh, I probably need to do what is it? Core.series.series. Core, not cores. I'm thinking of parallel computing. Okay, no, this is okay. Yeah, what I did before works. So anyway, what this tells us is that there is this method nUnique, and what it does is essentially gives you the number of, well, we saw what it does. It gives you the number of No, this is calling help on the on the result that's output from NUnique. But anyway, let's take it for granted that NUnique does what it says here. It provides you with, it counts the number of unique entries, and the difference between getting the answer by using that rather than using the call to length is simply that when you use call to length, what you're doing is you're creating this intermediate variable called site names as a query on the data, and which is composed of so you need to do an extra step of calling getting a list of a NumPy array with a number of unique entries from that query, and then getting the length. NUnique gives you directly the number of unique entries in that Pandas series returned from the data. So what that does is it avoids the creation of an intermediate variable. It might be faster. We'll look actually a bit later on how you can measure the speed of things, and this is not mentioned in the carpentry docs, but I think it's something useful to be aware of. There's a built-in function that we can access in IPython, which helps us time how long things take to execute, and we'll see that actually the syntax you use, even though there's often more than one way of getting the answer you're looking for, the way you go about it might make a huge difference to how fast your processing is, which might not be important if you are simply running this interactively to interrogate one or two data files occasionally. But if this is part of a workflow, if you're creating a Python script that's meant to be part of a workflow, and you're spending compute time, wall time, throughput, budget, all kinds of things, and just simply waiting for lots of data to be processed, speed matters, and using good Python syntax matters, and we'll see that in a little bit. So that's the challenge. Now we're going to move ahead and actually start looking at some actual statistical data generated from the statistical summaries about the data that we've ingested. So this is where Pandas really shows its usefulness at very quickly doing analysis of the data once you've ingested it and stored it in data frames. So the docs suggest that we look at the following built-in function. So if we take whichever field column in the data we want to look at, suppose we want to look at the weight. If we simply get queried for the weight, well, there's a lot of nans in there, a lot of not numbers, but there are some actual weights in there. So then what we can call on any of those series that are part of the data frame is we can ask it to describe. And describe in Pandas for a data frame or a series means give me a statistical summary. So give me the number of elements, give me the mean, standard deviation, the min, max, and percentiles. As what is the type of that? It is a series itself. So the summary, statistical summary of the series is itself a series. What if we'd not selected one of the fields, but simply asked, let's see, can we ask Pandas to give us a statistical summary of the entire data frame? We can, in fact. So that will simply be a new data frame. I think, let's check. Yes. So that returns a new data frame with a statistical summary of all the series within that data frame. It's a little bit difficult to see, but because there's so much of it. But yeah, you can see that here for a given field, it's summarized in that column, those stats as a series. So yeah, we could either, so here immediately comes our first insight into speed and syntax and how we go about things. So if what we care about is the statistical summary of, for example, the weight, as we started pointing out, then we have two ways to go about it. We can ask Pandas to describe the statistical summary of this entire data frame, as we just did. And then we can say, well, I'm in particular interested in the statistical summary for weight, and that will fetch me that answer. Alternatively, if I had started off by selecting the weight series and then asked Pandas to describe for me the statistical summary of that particular series, I get, of course, the same answer. It's just about a different order. However, in terms of performance, it might not amount to the same thing. So there is a built-in function in IPython, which is one of these IPython magic functions. It's not a Python function that you can call in a Python script unless you're using IPython to run it. It's called timeIt. And what it does is anything that follows the timeIt command, what IPython will do is it will execute whatever follows the timeIt command, and it will execute that code for a certain number of times, not just once, but however many times it deems feasible and necessary to get good statistics on the execution time. So it will, rather than executing just one time and getting saying how long it takes, it executes some code maybe 10 times, maybe 100 times, maybe 1,000 times, maybe 10,000 times, and then looks at the timing. So we can actually compare the performance of these two ways of getting the same answer. So we take our first approach that we took, which was to ask it to get the description of the statistics of all the data and then look at the weight. Give it a second to run to sample the time. It says that command takes about 7 milliseconds with plus minus some standard deviation. And you can see that it's done that 7 times, 7 individual runs of that command and run it 100 times each time. So it makes some heuristic rule of thumb decisions on how quickly and how many times to run it to get some meaningful statistics. Now let's ask it to time the alternative syntax formulation. So now I'm asking it to time how long it takes to give a statistical summary for, in particular, just the weight field. Yes, I am on mute. Thank you for pointing that out, Peter. Wow. Okay. Apologies for that. Right. So that means that what I have just been saying. So what was the last thing that you heard, Peter? You can tell me.
I think it was when we're comparing the times of how long it takes to process.
Oh, that's good.
Doing it, yeah.
Okay, so at least, so I must have accidentally, because I have there's a little physical button here which sometimes gets caught. So I think that must have accidentally muted me. Apologies for that. It's good to know that at least the entire story wasn't lost. So you heard me talk about the timeIt command.
Yes, that was it.
Right, and so the conclusion basically being that it can be a lot faster. So IPython is nice because you can test when you're prototyping code that if it's going to be used to process a lot of data or to process data very frequently, and the time that it takes matters, turnaround time matters, then you can use timeIt to, if you have alternative formulations to get the same answer, time which one is faster, and if it matters, use the fastest one. That's it. So good. I didn't lose out being muted too much. So the next step is you can look at individual statistics using these methods. I mean, that should really be the same as actually interrogating the, let's see. Yeah, it will tell you. No. Okay, so these are two different things. So it's good. You can see how I've misunderstood, how I've made a mistake that, well, maybe anyone could make, maybe none of you would. But so looking at these statistics, saying extract one specific metric. So actually, when we're getting this, so that's directly, yes. Okay, see what's happened. So rather than asking for a description, which gives us the summary of all the metrics, mean, standard deviation, min, and everything, we can directly ask for just the mean rather than all of them. So that's what the text is saying. What I did mistakenly was I asked for the description, and then I tried asking for the mean of that description, which does what? it takes the mean of the count, the mean, the standard deviation, the min, all of those values. So that's clearly wrong. And obviously just picking out the mean indexed labeled element of that Pandas series was the right answer, which is what you get if you directly ask for the mean. And it makes sense that only asking for the mean, presumably, will be faster than asking for the description of everything and then and only then getting the mean. Well, we already know that it will be because we can see that this takes 90 microseconds. So yeah, so yeah, so that's 16 times faster. So clearly it is a good idea to just ask for the metric that you want. So next thing that is really useful to start to interrogate data more intelligently is to use the group by method. So that allows you to selectively look at the properties of particular subsets of your data. So the example here is given by the sex of the animal that's sampled in the survey. So what you can do is you can say, I'm going to call it grouped by sex, because there's other kind of groupings we'll do later on. So you can so we've done something. We've called this group by method on all the data, and we've assigned it to a variable. You might say, what is the type of that? Can we simply look at that? Well, no, not really. Let's see, what about if we call our head command? Yes, that gives us some insight in that it prints out some of the data, the first n elements. If we ask for more, it'll give us more, but it looks as if we don't, visually at least, we don't really see the subset grouping necessarily reflected. So there's not like a clear representation of the fact that it's not like the first however many entries are purely one sex field value and the other remaining ones are the other sex field value. You know, you see they're intermixed here. The fact these are all Fs is neither here nor there. It's a red herring. So however, so we see that the type of object that this grouping returns is some kind of pandas object called a data frame group by object. The question is, how useful is that? Can we actually do something useful with that? Yes, it is. It's kind of an abstract. It's kind of like an abstract queryable form of the data. It's like a half filtered, half queried data frame. So that's my very informal way of describing it. But call it what makes sense to you. But the point is, what can we do with it? Well, what we can do is we can look at, we can further query that grouped data in order to generate insight into our subset. For example, if instead of asking for simply the entries themselves, if I ask for a summary of statistics, like asking it to describe the statistics of that data, now it will utilize the previously imposed grouping and present the output according to whether the field, for the grouping sex F or M, and it'll generate statistics for each subset of the data. So you can see how Pandas is very powerful once you've got stuff in a data frame. In that, quite a high level, you can ask it to group the data, and you don't need to do many of these quite arduous, maybe, manipulation of if Pandas didn't exist and you're reading in all this data into NumPy arrays, for example, because NumPy arrays are a good way to store data, if it's numerical anyway, and then you were yourself kind of writing code that applies a logic of, well, only select the ones that are, if the field is a, if F SX F or SX M. So this grouping is really useful for generating quick insight into your data. Now asking for, well, let's see what this does. If we say, if we ask now to provide the mean, and we don't specify anything else than that, so we're going specifically after the metric of mean, that doesn't seem like it generates anything useful, because sensibly, I mean, it makes sense, because what is the data? Well, it contains also non-numerical data, and what's the mean of non-numerical data? So as opposed to before, when we were looking at the mean of just the weight, for example, we're now asking it to give the mean of all the other fields other than sex. So that's not going to give us anything meaningful, or rather the meaningful stuff is going to be swamped by the non-meaningful. Actually, this is actually an error message. If you scroll sorry, didn't mean to suggest that it actually did something sensible at all, because in fact it generated through an error, saying it cannot convert all of these things, which are the species identifiers, into, wait for it, numeric. So it's complaining that the mean cannot be computed for those metrics. So that's why, fortunately, there's this little additional flag you can say, which is to say, yes, compute the mean, but only do it for those fields where the data type is numerical. And then that excludes things like the species ID, and does generate the metric you care about for the numerical values. Obviously, plot ID is not a meaningful thing to generate the mean for at all, but you can just ignore that, I guess. Okay, so that allows us to get insight into the data. So here's a summary data exercise challenge. So why don't you have a look at trying that one, and we'll regroup once you've had a chance to try that one. Yes, there's an excellent suggestion from Evgeny. So I didn't mention, sorry, I didn't introduce you, Evgeny. So I got caught away. So Evgeny is my colleague from EPCC who is helping out. I think my connection is poor right now. It says, how's my audio, Evgeny? Am I audible?
Yes. Hi, everyone.
Yeah, so the suggestion Evgeny was making is that to share your solutions on the Etherpad that he's linked again. So that's great, and I think you've been adding some, or somebody, maybe you, Evgeny, have been adding some summary of what was being discussed, which is great. So yeah, feel free to add your answer to this challenge, and maybe also how you arrived at that answer. That way, it'd be interesting to see if people have different approaches for different formulations for getting the answer. Probably just mention which number it is that you're answering, number 1, 2, or 3, to clarify. We can discuss it afterwards. Oh, actually, yeah, muted, but I'm muted intentionally. Thank you for checking. Better to check than assume I might not be talking. But no, I wasn't presenting. I just called up this, giving people a bit more time to work through the challenge. See, somebody's already shared some results, which is nice. Suggestions. we could have a quick look at the first question in the challenge and then give a little bit more time to look at the other parts of it. So I think somebody already suggested in the Etherpad as well that one way to get the question to answer the question of how many recorded individuals are female and how many are male, listed as male. You could, you could definitely look directly. So you look at the record ID. So the record ID is useful because it tells you how many how many records there were in the data where there is data for the description for the sex field being either F or M. And I say if there is data, because if you take the number of count for F plus the count, I should probably do this instead of copying and pasting. I should do this by accessing the values from the from programmatically. This is terrible. Yeah, I should really do that here. So I'll do it sensibly. I'll say count and then say I'm going to get into trouble here. Yes, okay, plus the same, but then for M rather than copying and pasting, since it's all meant to be about good. So the total of record counts of record IDs for F and M together is 33,038. But we know that the data that we have actually has over 35,000 rows or records. So that means that about over 2,000 records are missing. And basically, so any ideas, anybody why in the chat or otherwise why there might be this discrepancy? Nobody? Maybe it's too obvious for anybody to bother putting in the chat. But yeah, so the reason why there is this discrepancy is because we've asked in this grouping, we've asked the data to be grouped according to the value of this field sex being F or M. However, there are places where there was no data in the original input file. So that is what when reading the CSV, Pandas has parsed those empty values as nans, as not numbers, and therefore they are excluded from the grouping, and therefore excluded from the count, the cases they're excluded from the data that is added to the count for record IDs. Even though they have a record ID, they are rows where the sex was not set, where the sex was nan. So there'll be about just over 2,000 cases of that. Okay, so give people a little bit more time to do the second part, and we can talk about that. And if you have finished the challenge, and just put it in the poll and say yes in the poll. Okay, well, let's have a look at part 2 then. So what happens when you group these, when you do a grouping by not just a single field like sex, but if you group according to 2 fields. So for example, as it suggests here, if you do a grouping by, so you can see here the input argument we're giving for the group by function is not a single label, but it's a list of, in square brackets, a list of 2 string labels. So let's have a look at what that gives us. So that basically means that we're doing a double subdivision of our data into both plot ID and sex, and we're getting summary statistics for each plot ID, for each sex within the plot ID. We could have of course done actually the other way around. So the ordering in that representation is kind of reflects the ordering in our request for the grouping. If we'd done the other way around, plot ID after sex and ask it to plot it, then we would have had a subdivision the other way around, where, I mean, it's the same data, just visualized differently, right? So just to make you realize that you have that flexibility. So we can get further insight in, we can further subdivide, further group the data and get summary statistics on those further nested subdivisions in whichever way we want to hierarchically think about it. Then the final part, I think somebody did put an answer in the suggested answer in the Etherpad. So the question is to summarize the weight values for each site. So we're going to have some subdivision of so we can do it in multiple ways. So for example, we can look at we can group, I'll call it grouped by site. We can group by according to plot ID, and then for that data that's grouped according to plot ID, we can purely look at, well, we could first of all, we could look at the description of everything. But if we just care about the weight in particular rather than all the other metrics, then we just select out the weight, and this gives us a summary of the weight statistics based on the subdivision of the data into the plot ID. So let's see if there's anything that we've missed in understanding that. So yeah, so this first of all is describing this discrepancy in the data for male and female. Then we've talked about further subdividing our data into more than one group, nested, and getting statistics for those. And it suggests here that, well, it's not in the question, but it suggests that if you want to exclude some variables for which the given statistic you're interested in, whether it's the mean or something else, we're looking at the mean for that in part 2. If it's not relevant, like we know, for example, for the year, for example, the mean year, that is not that meaningful, but some other question, some other metric might be interesting. So then you can use this method called ag or aggregate. So there you basically what you give that as an input argument is a dict, which is saying for each of the fields in my data, such as for example year, such as for example weight, use not you can use a different metric, display a different metric. So you can pick and choose which one of the statistical metrics you want to show for each of the different variables in your data, rather than just showing the mean for everything, or so you can pick and choose. And if you formulate an aggregation like this, then you would yeah, okay, so the output isn't showed here. We can just try it. See what that results in. So that shows us something meaningful for this dual subdivision into plot ID and sex. And for the year, we've chosen max, so the latest year that there was a sample within that plot of that sex. For the hind foot length, we've chosen the median, and for the weight, we have chosen the mean. So this is kind of a useful way of summarizing the data. Okay. So now we finally get to plotting. So we're going to actually make some get to doing some visualization. Okay, that's the heading of this section. But actually, before we do that, we still need to. I'm going to do some counting. So the idea is basically that so we've so far used, after grouping our data according to something like sex or plot ID, we've used describe or aggregate or directly asking for a particular metric to get statistical summary. We can just do a count. So if we have grouped our data according to species ID, then we can look at only the Pandas series corresponding to the record ID, and for which we know which we know is a field for which every row in the data has a value, was assigned a value, and then count, do the count, and the count that will tell us how many samples there were with species values according to this this grouping. So yeah, so you can try this and try this challenge. Well, let's see what that looks like, just for completeness, rather than just talking about it. Right. So so we've grouped our data according to species ID, and we've done a count for each of those species based on the record ID. We've chosen the record ID because we know that every data point has at least, even if it has no other data, the fact that it's a data point means it has a record ID. So that is going to be the basis for doing a count. And this is simply a variation where, okay, if we want to access any given, the number for any given species, we just sample that labeled with a particular species ID. So yeah, next you can try tackling this challenge of making a list. So this is getting us ultimately towards being able to plot something shortly from now. I might get you to have a look at the plotting over the break, but it's we'll look after the break as well. So yeah, have a go at this make a list challenge. And again, yeah, by all means, put the share your answer that you've tried for this make a list in the Etherpad. Thanks, Evgeny. Cool. Okay, so just, I haven't put a poll for this challenge, but it's just a one-liner challenge, and we can talk it through now and then just before the break, and then you can maybe have a play with something. So the question is, so instead of using this particular way of getting a count for the different species IDs, is there another way that you can do it? Basically, it's hinting, saying you can use something like count or the question of other metrics on the grouped by data frame directly. So whereas in this case we were grouping by a species ID, then extracting explicitly the record ID and then doing a count, what this is hinting at is you can do a count on the grouped data frame. So if you do that, you could do, see, this is the same as before. You get a grouped data frame according to species ID, and rather than getting the record ID and doing a count on that, you do it the other way around. You do a count on data frame, on the entire data frame, and then get the record ID. Now, is that a good idea? Feel free to say in the chat whether you think that's a good idea. What do you think is a better idea? This to get the same answer, or the lines above earlier to get the same answer? In each case, you're getting out a list of species with the number, with their counts. Which one do you think is better? Any ideas? I'll take wild guesses if you want to have any. Exactly. Good question, Evgeny. or a good hint rather. So I'm on the verge of giving it away because we're on the hour, and I'd like to suggest people have a look at next bit. But yeah, the queue, yeah, that's right. Exactly, Rav. So that's what you're doing. It's the same story as before, where previously we said it's really wasteful to ask for a statistical summary description using the describe method for all the entity for the entire data frame, and then only extracting the thing you care about. Much better to extract the thing you care about and only get the metric you care about for that thing you care about, for that label, for that field you care about. Same story here. We had a quite efficient formulation if you were to time it, which was just extracting the record ID and counting that. But now you're asking to count the entire data frame, so all the things in the data frame, the record ID, the sex, and everything, and only then fetching the values for the record ID, which is a waste, so inefficient. So if you were to time it, you'd find it was slower. Okay, so we'll have a break now. By all means, you can start to have a look at it if you like, but no need to. We'll start again just in 15 minutes from now. So at quarter past. Quarter past 2. So I've just put some guidance in the chat, which if you were to already be trying the plot command, would be useful and necessary if you're doing it in IPython or Python in the terminal rather than in a Jupyter notebook, as I think the instructions in the data carpentry website assume. So I will also put that in the Etherpad. Basically, you need to do one. You need to explicitly import the matplotlib package, in particular one particular function from it, as I put in the description. And then whenever you issue a plot command, as in the example code, you need to additionally run plot.show in order to actually make the image of the plot appear in your operating system. But we'll talk about this once I start up again, and I'll put it in the Etherpad. Okay, time to try to see if we can actually plot stuff. So the first time we actually get some visuals, which is nice because we've done a lot of data analysis. We're looking at how you can get insight into your data, into your stats, and group the data. Now actually trying getting onto the first visualization part. So as I mentioned in the chat and just before the start of the break, and I've put in the Etherpad as well. If you are if you're trying to plot, if you're trying to execute this bit of code here to plot what we just worked out previously, the number of individuals of a given species, then for all of the species. If you're doing that in the terminal, you may need to do this little bit of additional thing to make sure that the plot shows up. So first of all, you need to import matplotlib.pyplot as plt, which I'll just pronounce as plot. And after the command like the one in the example here, the .plot command for some data, to actually show the resulting image, you need to execute plt.show with brackets. Now that should, okay, I'll do it and see if it works for me. If not, we can switch to the Jupyter Notebook because it should work in the Jupyter Notebook. Just check that it does. So it should work regardless of what method you're using. Let's see. Of course, I did not. I forgot to actually do what I advised. So in my case, anyway, that has worked. I'll put a little poll just for you to say if species counts worked. So I'll put a little poll to say, did that work for you? In other words, do you get the same figure? And if it definitely didn't work, you get an error or doesn't show, and you just can't get it to show. Now, by all means, say no, and you can mention in the chat what the issue is, just to show how this all works while people are answering, trying that, to show here in the Jupyter Notebook. So we've not been using Jupyter Notebook, as I said. I thought it made sense to do everything in the terminal, since we're talking about, since it's an ARCHER2 course, and you might be running remotely, and Jupyter Notebooks can be a little bit tricky to do remotely. So, so what I've done here is I've just at the very top, I've created this new Jupyter Notebook. You can see it looks like IPython in terms of the in and out. So I've simply started from scratch from the very beginning, import pandas as PD, then done pd.read CSV, read the survey's input file, had a quick look at the survey's data frame. Well, it all looks familiar to what we saw in the terminal. Then I've done the line that we did just before the break, which is to get the species count in the efficient way by extracting purely the record ID only from the data frame grouped according to species ID, and then asking for the count of the record ID. And then simply executing that plot command, count.plot, and asking it to do a bar chart, and that also that works in the browser. So the fact that this works is, oh, I see 2 people have said that the plotting doesn't work for them. So, okay, Alba, that you might be running into, so let's see. The reason why it didn't work, who knows, maybe that's because of your particular setup, I don't know. I assume you installed matplotlib with pip install matplotlib. That should be available. And if you tried doing, are you running in Jupyter Notebook, Alba, or are you doing it within terminal?
No, I'm doing it on the terminal.
Yeah. Yeah. Are you used to, do you get any error message, or it just doesn't show?
It doesn't show.
Doesn't show. All right. I had this sometimes where you could quit the Python session, restart the Python session, and just do these few commands. You lose your history then in case there's anything you want to keep, or you could start a new session. Just try these commands with import pandas, read CSV, do the species counts, and then make sure that before this, before actually doing the plot command, that you import matplotlib as pyplot.plot, and then do the plot command, and then do plot.show. Have you ever used Jupyter Notebooks?
Yes.
Okay. So if you cannot get it to work in the terminal, then that is an alternative solution to simply do what I've just done as well. If you are able to start a Jupyter Notebook and then work in there for image-based stuff, that would be an alternative solution. Yeah. Somebody else, I think, also answered no. Although no, that's changed now, so maybe it works for them now. So there's still quite a few people who've not responded whether that works. It'd be good to know. Good to know if you can actually plot, because this is the first time we're plotting something. So if it doesn't work for you, then it would be good to sort that out. Otherwise, you won't be able to do some of the remaining challenges. So I'll just give you a bit more time. But do if you have tried it and definitely doesn't work, then just say in the poll, and we can try and troubleshoot it. So what this has shown us, by the way, is that apparently, and very conveniently, a very, very quick way to plot something if you're using Pandas is that apparently if we have a Pandas series, we can call the plot command. So just to get some additional insight, we could ask what is that plot command all about, or what's going on. Oh, of course, I called it PD rather than Pandas. Oops. So you can in fact make a plot of a series or data frame. So apparently we can call this plot command on a data frame as well. You can see what happens. So this tells you something about the kind of options you have. So we're using the option kind equals bar to produce a bar plot. We can of course play around with that. So we could have changed kind equals bar to kind equals pi and gotten it to generate a pie chart. So I see one other person has said that they are not able. Marshall, so you've got what's the issue? Do you know? It's just not appear, just like for ALPA after you plot. Yeah, so that's typically what happens if you haven't. So have you done an import matplotlib.pyplot as plt, and then after what you've just pasted in, if you do plot.show, plt.show.
Yeah, I might as well just speak. It makes it a bit easier. Yeah, I input the import matplotlib.pyplot as plt, and then go through the plt.show as well, but it just kind of doesn't pop up with anything.
Yeah.
It doesn't say error message or anything. It just doesn't do anything.
So sometimes the little window can get hidden and it's all tabbing or looking at whatever it's because it shows up, for example, I mean, I don't know what kind of OS that you're running. Which OS are you running?
I'm on Windows.
Yeah, because I don't know exactly how it shows up there. I mean, it shows up, for example, as a separate application view in macOS anyway, as a visualization. So I don't know exactly how it'll run in Windows or how it'll show up. So one thing you could try is just like literally was saying to as well, so that if you exit and like I just start a session again, do import matplotlib. If it's remembered it, that's great. Import pandas. What I was doing in Jupyter Notebook actually, so you can see, and all I need to do then is to surveys df equals that. It's very nice how to remember stuff. Then do the count, which I will just get from here. And then species. So that first of all doesn't do anything. So yes, that does work. So that's all I can suggest. If that doesn't work, then I think the only suggestion I then have, or the easiest suggestion I have then, which is most surefire to definitely work, is to use a Jupyter Notebook instead of IPython in the Anaconda command prompt. So yeah, you should. Have you ever used a Jupyter Notebook before?
No, I've actually never used the Jupyter Notebook before.
Well, I mean, if you can use data path. Oh, that's interesting points. Could you clarify what you mean by that, Evgeny? So
you can change the path pd.read CSV path to where your CSV files are.
Yes, but I would imagine that if the CSV file was not found, or if it was ingested with some error, then presumably before the point where you get species count.plot, it would throw some kind of error, or maybe that's not what you mean. It would already complain before then. So I can quickly, for anybody who is not familiar with Jupyter notebooks, but who's facing, for example, this either just wants to try or is facing this issue of not getting the visualization, I'll just take one step back from actually showing how to launch a Jupyter notebook. So I say show you, but again, if you're using the Windows installation of Anaconda, I assume there's I think there's like an option in, sure, definitely for you, if you launch Anaconda Navigator, which shows an overview of all the things you can launch, then Jupyter Notebook shows up as a thing to launch there. It might also be directly accessible from the start menu, like start and search for Jupyter Notebook. What you should get then is something that looks, as I'll show you in a second, which is that if I launch it, in my case, from the terminal by typing Jupyter Notebook, what I get is some initialization, which might be invisible for you in Windows potentially, and then it opens a browser. So there's some notification here of the server. Basically what happens is it launches a local server, web server. Yes, that's another good solution. Thank you, Thomas. Yeah, another solution instead of relying on the operating system to interactively render the plot, to actually save it as a file. Just to complete what I was saying, yeah, running a Jupyter Notebook gives you this interface. First of all, you arrive in this interface, which is basically showing wherever your local directory was. And then you can create a new Python 3 IPyKernel notebook. And what that does is it will create an actual notebook that will allow you to work as if you're running an IPython session. It says IPyKernel because essentially it's this IPython. That's what's under the hood. That's what's running. Just like that's the interpreter. So you have access to these magic commands, to time it, etc., and pwd to show the shift enter. So instead of pressing enter, you press shift enter to show you all where you are. Shift enter, and then you can use all the same commands as with in the terminal. But yes, Thomas was saying that's a good solution as well. It's definitely a good thing. So you just after you run the .plot command, you do plt.savefig with a file name, and that should I think it bases the output file format indeed on the extension that you give it. So PNG is a good decent one. So then it will write the file, and you should be able to open the picture in your operating system just within the directory where it was saved. So that's also something to try. So it looks as if most people, yes, Alba, that's also something you could try potentially. It's in the chat. I'll put that in the Etherpad if Kenny hasn't already. Yes, thank you, Kenny. Very perfect. Great. So it looks as if most people have managed, those who've responded anyway, have managed to plot, which is great. So if you haven't already, then by all means, after this, let's see, after that initial plot, try, well, there's yet to try this plot here, and then maybe paste the result into this is for getting total number of animals for each site, rather than the total number of instances of each species across all sites. So if you can share that plot, I think you can actually paste a plot into you can copy an image into the Etherpad, and then try out this next challenge with a plot of average weight across all species per site, and the second one, plot of total males versus total females for the entire data set. So that'll take a little bit of time. So give you a chance to play around with the logic of the selection of data and the plotting. Yeah, Andrew, it's a good question. Is there a new figure pointer for each plot? I'm trying to remember. I think it reuses. I think it reuses it. At least I know from experience, like at least with saving the figure, I can't remember, but it's, yeah, I think I think if you plot again, it just refreshes or overwrites, so it reuses the same. I think you can do a named one, but I've always just done it once and then I either saved it and then that's it, not really cared about it. There's just been one question to clarify a little bit the syntax, just for being absolutely clear in this bit of code here, which is that. So the question is, what is kind of happening here with the two, with the syntax of the round? Yeah, so what is the syntax here? So you've got in braces, parentheses, I should say, the plot ID, and here square brackets, the record ID. So what we've got on the right hand side is here. Let's start off with this. This is our underlying data frame surveys DF containing all of the data that we've read from file. Then we've called this method group by, which is a method called on that instance of on that data frame. So saying for this data frame containing all our data, group it according to what? According to, well, the group by is a function, and the function takes an argument. So these round braces, these parentheses, allow you to give the input argument of what you want to group the data frame by. And here we've said group it according to this field called plot ID. So what that is, it doesn't in and of itself sort of show us anything unless we further interrogate it. So if we then ask for, so basically this is saying group all the data according to plot ID, and then it's saying then with the square brackets you can select only that data out of the grouped data that corresponds to values of the record ID. So let's see what that looks like. So yeah, difficult to say what it looks like because it's not very descriptive. But let's see if we can. Yeah, that's also not very descriptive. If we ask for some stats, that will make it possibly a little bit clearer what the actual data is. So what we've ended up with is what we've ended up with is a summary of the different statistical values. If we just look at the mean, maybe it's easier because so instead of asking to describe, I'm just asking for the mean. So essentially what we've done here, we've asked for the mean of all the data, all the record IDs for each for the data according to grouped by plot ID. So what we're seeing here in this first column is all the different plot IDs. So plot IDs are the different geographical survey locations, and there are 24 unique geographical survey sites. And what we've done is, so this value here is the mean of the record ID the mean of all the record IDs for that site. It's not a very meaningful value. It would be more useful to get like, I don't know, the count or something, I don't know. But basically it's taking, so for a given, by grouping this data according to plot ID, whatever we're going to look at after, based on that grouping, is going to be split up according to the plot ID. So anything we look at based on that, after we've done that grouping, is going to be subdivided. It's going to be a subdivision of the data set into these 24 plot ID values. And any statistic that you look at will then be for those plot IDs. And if we look at the record ID, then yeah, we can. This is then the mean of all the record IDs for that plot ID. So I hope that clarifies a bit So the difference between the syntax with the round brackets and square brackets is the round brackets here for a function call, the method called group by, and that takes an input argument, what we want to group by. And then this square brackets is an index into the into the grouping, into the group data frame. I want to use simple terms like an index into a list or an index into a Pandas series, but this group data frame is a whole object of its own kind, which is like, you know, an abstract thing. It's a grouping of data frames. Okay. Right. Oh, Andrew, sorry. Yes, your question. Possible to instruct Pandas to create a new figure pointer? Yes, possibly. Yeah. Thank you, Evgeny. Yes, there is a way, and actually, it's not a Pandas specific way. It's kind of more matplotlib way, and matplotlib is the underlying visualization package that the Pandas plot command uses. I think it builds on top of, and we'll cover matplotlib in one of the later sessions as well separately. So it might get resolved there. I don't know, but yeah. Right. So let me just put a little poll out to see if people have. Well, let me have a look in Etherpad. Nobody shared any of the plots of the total number of animals per site or the challenge plots. Let's see some plots. I'll put a poll anyway. No, it looks like people are still working on the challenge plots. I'll assume that's because of the logic of trying to get the right data, rather than because people aren't able to plot, or at least in maybe only one case or two cases that plotting in itself doesn't work yet. So I'll give people some more time to try and select the data to plot. I can see someone typing in the Etherpad with a code. Thank you. Yeah, copy paste. If copy paste of an image doesn't work, looks like in the Etherpad at the top of the screen there's a image that looks like an icon that looks like two arrows on top of each other, one on top of the other, which allows you to import a file. So you can essentially, I think, upload a file, possibly an image file as well. So yeah, if you wanted to try, if you wanted to share your plots, what you could try is doing the save fig approach to save figure as a .png, for example. And once you have that file, once you have that plot saved as a file, then you can go to the Etherpad and use the import export and see if you can upload that image. Up to you. Be nice. See if it works. I think what I tried was simply doing in Jupyter Notebook, doing copy image. I mean, if your savefig doesn't work, but you are able to see the plot, you can also always do a screenshot of the plot, and then that gives you a file that you can upload if savefig doesn't work. Yeah, Andrew, I just see your question. Just in your question, there's some there is some stuff about time series plots in the plot9 episode. So yeah, whether it covers everything that you're interested in, I don't know. See when we get to that. It's always a question of trying, detail versus. Hopefully, what you'll get is at least enough that allows you to find out afterwards if it's not already covered and to confidently handle it. But we'll see once we get to the plot9 whether it covers what you're interested in terms of the time-based time series stuff. Okay, so in the interest of time, let's just have a look at the first one of these first challenge, which is create a plot of the average weight across all species per site. So for each site, we want the average weight across all species. So what that means is that we first of all want to group, so we can group we can create a grouping of the data by site, and we could then take that and extract purely the well, I've done it in 2 stages, but that's unnecessarily convoluted. So we can yeah, no, let me do it in 2 steps because it's because it's clearer conceptually, even if it's not more elegant or natural somehow. So first, grouping all the data based on the site, i.e. by a plot ID. Then computing the then taking the weight field from that site grouped data and taking the mean. That we should have our mean site weights. And if I then should be able to plot that. So yeah, so that gives us the mean weights for each site. So that's one option. That should be fine. So that, yeah, that works. Again, it's just a case of 2 subdivisions. And then for the second part, I don't know if anybody had a chance to do that. Let's see if the solution for number 1 agrees with that. Based on plot ID, taking the mean. Yes, so it's so here they've taken the mean of all the data and then extracted the weight, whereas I've gotten the weight and then got it to calculate the mean, so it's potentially a bit faster. I don't know if it matters. You can time it. So if we want point 2, we want a plot of total number of males versus total number of females for the entire data set. So how can we do that? Well, we'd want to clearly be grouping all our data according to sex, and then we would want to count for each subdivision, as we know that the field that we can look if we want to make sure all the data, all the rows, all the data points are included is to look at the record ID, because whatever data is included, it always has a record ID. The record ID is never a nan. So if we for that sex subdivided data, if we ask for the record ID and we then do a count, that should give us the totals for each. Let's just confirm that. Yeah. So that simply gives that, not much of a bar graph, but yeah, that's fine. The same thing they've done. Yeah, same thing, same approach. So then for the for this summary plotting challenge, so that'll be the last thing to work on. That's potentially a little bit more involved, so we start working on that now, and then let's see. I think we've got another wee break scheduled at the hour. I think. Let me check. What 1/4 past? Yes, that's right, on the hour. So we've got another 15-minute break coming up at 3 o'clock. So we'll just consider it now. Think about what this summary plotting challenge is asking. So now we're looking at creating a stacked bar plot. So something that looks like so for the following, with the weight and then stacking the 2 sexes, the 2 values for the 2 sexes on top of each other, and then doing that across sites. So there's some hints here about how to create stacked plots for a very simple example where you've got, you can think of this as a case where you've got sites A, B, C, and D. So have a look at the documentation. It's a little bit more involved, and see if you can work out how to do this. There's some transformation method unstack. So there's so you can have a read of it, but essentially unstack, what it does is it kind of moves around the, I wouldn't say flatten, but it wouldn't say flatten data, but it moves around the logical ordering of the data. And if you get a data organization, like for example, like as is shown here, if you were to run the unstack operation 4 times on the same data, I think you get back the original data. So it's basically reordering of swapping of rows and columns again and again to highlight, so that you can plot whatever you would want to. So you just need to figure out how to reorganize the data. I think somebody already said they were playing around with that. Yeah, so give people a chance to work on that, and we can have a look at that after the break. At 3:15. So we'll be back at 3:15. Okay, so let's see how things are going. I'm not going to do a poll, but I'll actually, in the interest of time, go straight into discussing this plotting challenge and looking at how we can get something sensible out that we want. Yeah, so we have enough time left to hopefully do the majority, if not all, of the next episode during the rest of today, in the final session today, the final hour. I realize it's difficult to keep doing this for a whole day, like concentrating, and I'll ask for some feedback at the end of today's session as well, just to see if the pace is about right. It's always difficult to know how to pitch these sessions because with the live coding for carpentry, you're meant to go at the pace where you can do everything, talk through it and show it, and have people follow along as well. But it's always difficult to pitch. But yeah, I'll ask for feedback, and potentially we can speed up tomorrow if people say today was definitely too slow. We'll see how far we can get. The most important thing, I think, is always to help everybody get as much out of it as possible, whether that's figuring out basic stuff or figuring out how to find help documentation. As I said in the beginning, I think it's more important during these sessions to help people figure out roughly what's possible and how to approach things, teaching people how to fish, how to find help and figure out stuff, rather than covering necessarily super advanced things and providing specific commands that are super advanced for anything. But let's talk through this question now. So what we're after is a stacked bar plot for the total weight by sex for each site, with the 2 sexes stacked on top of each other for each site. Okay, so it's clear that we want a grouping based on the site and based on sex. So we're clearly want to do some kind of grouped, let's say by site and by sex. That will be the surveys data frame dot grouped by 2 things again. So the plot ID, which is the site, and the sex. Let's see here. Yeah, okay, so they've done that ordering as well, just for convenience, in case you're looking at the solution through the same order, plot ID sex rather than sex and plot ID, because unstacking might work slightly differently in that case. Oh, okay. Yes, group by, not grouped by. So, okay, so that is grouped by plot ID sex. And then the thing we care about is the weight. So we can say that grouped weights equal to that grouped by site and sex, and purely the weight. Okay, so what does that tell us? Well, whatever it tells us, doesn't tell us the tells us the count for each sex and the mean weight and the standard deviation. We don't want that. We want the total. So what do we do to get the total? We take the sum. So this will give us, so it's a double subdivision, nested subdivision top level subdivision based on plot ID, then within each plot ID based on the sex. Now, if we want to plot this, we will actually need to supply this. If you sort of look through the example, the logic of how you produce these stacked plots, what we actually want is for each plot ID as an index, we want 2 pandas series, one for the total weight for the males and one for the total weight for the females. Sorry, not for each plot ID. The plot IDs 1 through 24 form the index of the 2 series, one being for the weights of the females and the others for the weight of the males. Now, the way to generate those 2 panda series from this, what you see here, this nested subdivision, is to use the unstack. So if I'm going to undo the describe and I'm going to ask to unstack this, that's exactly what we want. So what do we see here? This is presumably the type of this is a data frame. Yep, and composed of 2 panda series. That's great, because then what we can do is we can essentially plot that. So we can say dot plot on that. What kind of plot do we want? Again, a bar, and we want it to be stacked. Yeah, apart from the color difference, I think and a slight difference in the choice of scale, the y-axis limit on the example is chosen heuristically by Pandas to be slightly different. That is it. So that gives you the what we're after. So hopefully this episode, lesson, whatever you want to call it, has given you some more idea about how you can interrogate your data by various calls on groupings on data frames, aggregation of summary statistics, and also how to use direct plots of multiple pandas series, one or more pandas series directly, which are based on matplotlib. So if you have any questions about this session, or this lesson, or this one I showed just now, please feel free to ask. Otherwise, meanwhile, I'll move over to the next section for the remainder of today. So this is all building up to stuff that's important for accessing the data that you care to manipulate and analyze and visualize, etc., etc., etc. Okay, so I don't see any questions about last session, previous session. So so we'll look at this episode now. This is they're numbered. It's at number 4. So as I said, we'll see how far we get with this, and then there's a fair few left for tomorrow. The schedule for tomorrow as a whole is slightly less time, I think 1 hour less than today. But depending on the startup, there's a startup cost today of getting started. So we might go a little bit faster. As I said, I'll ask for feedback at the end of the session just now. So let's have a look at that. So the idea of this episode is to select essentially subsets of your data, not in the sense of groupings according to particular values of fields, but accessing a bit more conventionally, kind of just a range of values for a given field, say, and then also some how to apply selection criteria to your data. It could be simple index-based range, or it could be based on a particular conditional property of the data. So we still keep using the underlying same surveys data, and the first bit of this is about looking at this is just what we looked at before. Essentially nothing more than basically showing us how we can index the data. So we already saw that if we want to access one particular panda series corresponding, for example, to the plot ID, that will tell us, that will give us the corresponding panda series as part of the data frame. So there's a reminder here about some reserved keywords. So then we get to one of the key ways of selecting subsets of data, which is called slicing. So slicing is simply a way of taking, let's say, within a given, along a given axis or along a given dimension, taking a subset of your data. So if you've got a list of numbers here, then as we are familiar from the first lesson today, we saw that if you access the 0 indexed element, that will give you the, this will give you a the first element. In some programming languages, in arrays or lists, start at 1, but in Python they do start at 0. So they give you the first element. 5 will give you in principle the 6th element. However, when we defined A, we had 1, 2, 3, 4, 5 values. So there is no 6th element. So that gives you an error. Then question about the same question. Length of A is 5. 1, 2, 3, 4, 5. That's the length of A. That gives you, so this will generate the same error because again we're asking for the element with index 5, and there are only 5 values, and the index of the 5th value is 6. So that's basically repeating some of the things we're already familiar with. The only new thing really is this the syntax here, which you may have come across before, which is that the -1 index is used to access the final element of a list. So instead of checking what the length of a list is, then subtracting 1 to get the index of the final element, you can just use -1 directly. So that works in Python. When it comes to so that's addressing individual, that's getting individual elements. So now we're going to talk about slicing in particular. What slicing is getting a subset, getting more than one element, but getting a subset of all the elements. So essentially what slicing is saying my slice of the data along a particular dimension starts from a particular element indexed by a value and stops at a particular index. So basically you're saying from here until here, give me a slice of my data along a certain axis from this value to that value. So in our data frame, for example, the syntax, so the colon syntax with an integer index before and after, that defines the start and end of the slice, and the dimension here that it by default assumes for data frame is the rows. So what this will give you, surveys data frame 0 to 3, is, let's just first, oh no, we already have the, well, we have the exam. Well, let's just plot the entire head of just the first few values, first few rows of the data frame. Now, if we ask for the slice from 0 to 3, what does that give us? It gives us the first row with index 0, and the second row with index 1, and the third row with index 2. So it stops. It's 3. It's up until 3, not up until and including 3. Right. So that's pretty straightforward. And what you can do is, start at an arbitrary point. So that syntax is pretty intuitive. And if we want to go until the end of the rows, so if we want to start at row, I don't know, 100, and end at, take all the rows from 100 until the end, then we simply make sure that the final element, it goes up to and including, no, it's up until -1. So the element, no, that's a good, so mistake, right? So this will stop before the final element. So this actually excludes the very final row. So if you want everything, then you actually specify nothing as as a stopping point. So there you can see 3, 5, 4, 4, 8 rows versus 3, 5, 4, 4, 9 rows. So that's how to specify a slice that stops doesn't stop at any given final value until it reaches the end. If you simply say that with a colon and no start, no end, that's equivalent to the original data frame itself. So, right. So that's that. And you can similarly start from 0, and well, you get the idea. Go to an arbitrary value. That's pretty intuitive. So that's how you can get values. How you can get subsets of your data frame. So there's something to be aware of when it comes to Python. That yeah, so you can, if you want to modify, so there's something to be aware of when it comes to Python, which is that when you are taking copies, so when you say that two, right, let me just make this more concrete. So we had our initial example list, which is this list A. Now, if we say that our list B, some new variable B, what do you assign to B? We assign that to list A. A is that, B is that. Now, if we modify some entry in B, oh, too large. We modify an entry in B. B is therefore clearly modified, its final number of entry, but so is A. What happened is that when we assigned, gave B the assignation A, B did not get a copy of the data in A. It gained a reference to the same underlying data. So as a result, when we modified B, we're modifying A. So this is important to keep in mind because it might catch you unaware if you have not come across this before. And that's what this is saying essentially. So it's saying that if you're going to modify, for example, if you have your data frame and you're going to modify the something that is so if you've said, okay, I've said an entire data frame is equal to a new data frame variable is equal to this original data frame variable. That is exactly the same kind of assignment equivalence that you're making here, where this new data frame variable ref surveys df now refers to the same underlying data frame data as this surveys df. So if you change any of the elements on purpose, or if your code inadvertently does this to what you might think is a copy, you set some values to 0, for example, which you can do even for a slice. So what this slicing syntax does here for assignment is it basically says set all those rows, set the values of all those rows for all fields equal to 0. That also affects the original data. Now, the way to avoid that is to use an explicit copy command. So this is mainly important. I mean, it's mentioned as an aside because it can catch you unaware if you've never come across this before. And there's something to be aware of in Python generically with regards to any object, really, whether it's a list or whether it's a data frame. So it's just something to keep in mind. And this here explains and demonstrates and gets you to test if you like, see that this is true. So this is simply a warning to be aware of, to keep in mind. Okay, so then a little bit more about Python, indexing. So for data frames, so we can use, so far the slicing that you saw was based on a single, a slice along a single axis. So here, so what we had so far was just above here, we had our data frame. And for example, here, I hope that's big enough. I'll just make it a little bit bigger. Maybe it's easier to see. Here we're asking for a certain subset of rows, but for each row we were getting all the column data. Now we can do a multidimensional slice where, as this example shows here, let's see if we can do this. So let's take the first few rows and let's say, what do we get if we ask for, so yeah, so this won't work directly. So we need to use the slicing syntax that's specified here. That will allow us to do more advanced multidimensional slicing. Right. So this allowed us to do slicing along a single dimension along the rows, select a subset of the rows. We can use, however, the iLock method. So there's two. The point of this is that there's two methods. There's the iLock slicing method and the lock slicing method. Thing to keep in mind would be that lock. So the I would be standing for integer, and lock can handle a slicing specification that is not purely numerical, but can also handle slicing specification that includes text labels. That's the essential difference, the essential idea. So this is not, necessarily conceptually, I think, necessarily very complicated or involved, but it's mainly something to be aware of and something to get some practice with. So rather than me dragging you through the explicit explanation of this, I think I can trust you to maybe take 5 minutes to have a look at, however long you want actually, to have a look at that documentation, that description of iLock and lock, and see if you can make sense of this challenge and work your way through that and figure out what's what based on the explanation there. And then we'll pick up again. I'll put up a poll. We'll pick up again once you've had a chance to work through this, because this will be useful to be in command of when it comes to selecting your data. Okay, I see some people have responded. They've managed to get through this challenge. And one more. I think the main thing here is basically, I mean, you can get familiar with this kind of as and when you need, and just remind yourself, just to be aware at the very least that there's two different options, the iLock and the lock, to make sure you use the right one. The interesting conceptually, one question maybe to think about is the difference between these last two commands. So as it says, does anybody want to suggest what the difference is between these two commands to explain, either in chat or by talking? Yeah, that's right. So you cannot index the columns, at least the majority of the columns, by actually, in fact, any of them, by numerical indices. So lock will attempt to identify 1 through 4 as being somehow indicative of text labels which don't exist. But whereas iLock will work, and it's kind of the equivalent of what I was trying to show to do and fail, first of all. So you need iLock to be able to do numerical indexed selection of columns, either individual columns or column range. Range of columns, so slice essentially to add the second dimension slicing. But for the lock, that won't work. And instead you can use the lock to include column label based identification. So I think there's an example here, but these named columns 1 through 4 don't exist. Okay, so then we get to something that's actually really useful, and one of the typical things that you want to do often, I suppose, when you're looking at your data, is you want to apply selection criteria. So you want to so not just group your data according to group it according to what values for particular fields are, and summarize and sort of subdivide it in that way. But you want to specifically say, in whatever context, whether it's at the plotting stage or at some initial data selection or cleaning or whatever, you want to only extract those entries from your data frame which satisfy, for which particular fields, which a particular field or particular fields satisfy some particular criteria. So for example, the example, very pertinent example given here is if you only care about the survey data for a particular year. So regardless of any subdivisions in your data or not, you could start with the basic underlying data frame without any grouping, as they do here, or potentially the grouped data frame. So this following syntax is a very useful syntax. It's not immediately obvious what you're actually to logically sort of understand the syntax as being consistent with previous syntax. But what this is essentially doing is it's saying, give me all the data in the data frame for which it is true that, for which this conditional set is evaluated. This is true, namely, for which the year field is equivalent to 2002. So that's great. So as you can see here, if you do that, then it gives you a subset of all of the data for all of the other fields, as long as it's true that the year is equal to 2002. Or indeed, you can formulate this condition, the selection criteria, based on other combinations of conditionals, like saying if it's anything other than 2002, or if it's greater than or equal, given that these numerical values, greater than or equals to something. So that's one conditional. And so you build up a compound conditional, and it's also true that the year is less than or equal to 1985. So then you're selecting a subset of your data. And you can immediately see how this is super powerful. And this syntax is a really quick and easy way to apply selection criteria to your data to interrogate and then plot your data. So one interesting question might be, what does that output? Well, so if I ask, so I can plot it, and if I ask what is the type of that data, it's again another data frame. It's just a smaller data frame, a data frame which has only a subset of the data from the original data frame. So that is useful, and then you can immediately use that as a basis to plot. Yeah, on the basis of that, let's have you try this challenge, which involves formulating some appropriate selection criteria to get that subset of the full data. Yeah, so Peter, to answer your question, I think you would form a, I guess if you yeah, there's probably a cleverer way to impose the requirements that it be in sites DM and in AH than simply compounding and with an and the condition that it is in DM and is in H. There might be a single, there's a better way to do that with a single statement, but I guess a compound of the negation of being in M or F combined with an and for being in DM and being in H, I guess logically would be a selection criteria conditional that could should be allowed to filter that. Okay, so let's have to think about the first one of those. First one in the query, in the challenge. So what would you want? You would want to satisfy where data from the year 1999. Well, that's easy enough. So that would be on its own. That would just be this statement. So where Well, I've encapsulated the conditional here. Not because it's just one conditional, don't need encapsulation. So simplest would be just like this, where the year is equal to 1999. All entries in data where the year is equal to 1999. Oh, by the way, this is an alternative formulation. I mean, the syntax that's used actually here is slightly different. So there they use dot year, which also works. So that's good to know. So that syntax is new. So we just kind of skimmed over it, and rather than using the syntax we're already familiar with, which would be from before, which would have been that. Doesn't really matter if you use what quotation marks you use, but that's the syntax we're using so far. Yeah, thanks. Okay. So okay, so that's first part of that question. That's 1999, and that contained weight values less than or equal to 8. So then we want, of course, to add an additional conditional to form our selection criterion, which is that surveys df. I'm just going to use this syntax. Index by weight. The weight must be less than or equal to 8. Probably don't need to put 8.0 as a float because Python will sort that out. Yes, that makes sense. And the question is, how many rows are we going to end up with? 1, 2, 3, 4, 5. I mean, I can get it to tell me the length of that instead of counting like an amateur. So, okay, 5. So that's, yeah, that makes sense. Let's see what they did. Yeah, yes, it's the same thing. They're saying if you're only interested in how many rows meet the criterion, the sum of true values could be used. Sum of true values. So then they're saying, okay, yes. So, okay, what is that? How does that make sense? Just to help, they've skipped something here in the explanation. So what this has implicit in this are two things. One thing implicit is that essentially this conditional on its own. Let's see if we can get it to output this. Yes, this conditional on its own effectively acts as a mask, if you like. What do I mean by that? What I mean is that this conditional requiring that a year column evaluates to 1999 effectively returns presumably a series. Yeah, a series of values which are either true or false. True for rows where this is satisfied, false otherwise. And when this conditional is used together, so with this second conditional, which in and of itself similarly returns a series of false or trues, then we're taking the conditional, this and the second one here, we're formulating a joint conditional, which in itself will be the rows, each of which rows is in itself a conditional of whether, for each row is false and false is false, says false, etc. And then we are effectively using that as the input argument for, that could be the input argument for the solution I gave, which is where you use that to as an index. So essentially, you take this joint mask, and this tells you actually retrospectively how the syntax, which at first seemed kind of miraculous, how it worked, what's actually happening, because we're asking for basically those entries within the survey's data frame where satisfying we don't give us the entries where the joint conditional evaluates to false, but only gives us the entries where the joint conditional evaluates to true, which is very few entries, none of which are shown in this abbreviated summary here. So that tells you how effectively that syntax actually works. And the answer that they've given here for calculating the number of rows in what would result if you were to use this joint conditional by taking the sum of all the true values, taking the sum of all the values in this column of the joint conditional. The second thing they haven't told you is that when that false in Python is actually equal to 0 and true is equal to 1. So when you take the sum of lots of falses and 5 trues, you get 5, which is the same as a length, which is the same as a number of rows you would get, i.e. the length of the resulting data frame fetched by selecting purely the entries that satisfy this conditional mask. So that's a whole lot of words to just explain why this answer actually also works. There's a couple of things I haven't told you there. Thanks, Andrew. So okay, so yeah, so so you've simply done a is in DM or AH if that satisfies both. If that satisfies the end, great, thank you. So that's the answer to the first part. Let's have a look at the second part, the is in command. So in fact, that's what Peter was just asking about, how to use this is in. Use this is in function to find all the plots, not Python plots, find all the sites, all the plot IDs where a particular species are found. So I guess to take an example, if you take two species, PB and PL, yeah, this is similar to basically what you're working out in the chat here. Find where the species ID is in these, and then you could potentially, so it's saying, it's showing for these two, it's actually all 24 sites have those, but if you were to select fewer of them or be more strict in that criterion, you'd get fewer hits. So yeah, that's that essentially. Other queries, you can experiment with other queries. Query that finds all rows with a weight value greater than or equal to 0. I think that's kind of in line with what we've been doing already with the conditional greater, smaller than or equal to 8. Yeah, it's very similar in syntax, nothing new conceptually. And finally, the negation symbol is, you can use it to is not in, and this yeah, so this as the example in the chat shows as well, it allows you to basically find something where it's not the case that it's on either of those two values. So this gives us a number of tools again to do more. So actually the next bit of explanation here is about using masks to identify a specific condition. So essentially this is what I was just explaining, what I was already doing in terms of this answer with the sum and what I showed with falses and trues. So the syntax actually generates a mask, which is a Boolean mask, which is either true or false. And that then gets used as a selection criterion. So what's useful is that there is so another very useful function that can be used to select. So we already learned about the is-in method, which can be very useful. Another very useful built-in method is the is-null method. So is-null, if you ask a data frame to return if you ask where the either a data frame or indeed a series is null, you're essentially asking. It's a built-in function, built-in method that can be called from Pandas sort of root package itself. So pandas.isNull. If you were to ask this of the entire data frame, what you get back is a data frame, something with the shape, same number of rows and columns as a data frame, with falses or trues, namely true where there ever is a nan in the data frame, which, as you recall, is what Pandas decided when it did the read CSV, when it encountered an empty value or some other contested value that it couldn't parse, it would label it as a nan. So this will show you wherever that is true. And you can see, as we saw already with the weights, there are quite a few weights for which there are nans. So then the mask, which asks is null for the data frame, returns true in those specific locations. So that can be used in turn as a mask and then therefore as a selection criterion. So for example, in the following way, where asking for all the entries in the data frame where it's true that you have not just this is null, but in particular, in addition, this .any. So this .any collapses, which basically says if there is any row for which, and row or column depends on this axis choice, axis being 1 or 2, but it asks for if there's a null, a nan in any row for this data frame, then don't give me out the original values of a row, just completely ignore that row. So this will be a way of in one line cleaning up your data to exclude any data where any of the fields are nans. Of course, you could be more selective than that and just or less selective and just only exclude ones where the weight is a nan, but this eliminates any of them. There's more information about how to tackle nans or nulls in the next lesson. So yeah, I would say challenge putting this together. This last bit. So yeah, the last few minutes we have left until 1/4 past. Let's have a go at doing this, and then we'll finish. I'll try to finish pretty much on the dot 1/4 past, so not much time left for this, but see if you can figure it out and maybe have a play with that between now and tomorrow as well, potentially. If you want to answer this question already, what does this do? Feel free to put it in the chat or in the Etherpad. Any thoughts on what this construction returns? Feel free to unmute and tell everyone what you think. So let's try it. So this doesn't look particularly informative. However, we can understand what's going on. So we've used this construction that we just discussed. What we're asking here essentially is give me the data from this data frame where it's true that the weight is a nan. And then from that new data frame where that is the case, give me all the weight values. Well, obviously, if we've constructed a data frame where it's true that weight was a nan, and we look at all the weight values in that data frame, they're all nans. So it's not particularly informative. You probably want the opposite to clean your data, namely negation of that. If you negate them being null, the weight being null, and base, you wouldn't call it empty weights then, call it non-zero weights, then you get all the data. It shows you the weights which are in the data set, in the data frame, which now is all the data where the weight is not a null. So that's typically more what you would want to do. Okay, we can have a quick look at this tomorrow because it is now 1/4 past. So just have a quick before we leave. I just have a quick question. I'll do a little poll just to judge the speed at which we're doing things, whether we want to speed up or slow down or keep it roughly the same pace tomorrow and see what the consensus is. If you just give me 1 second. fast. Okay, voting is open now, and feel free to give your feedback, and I'll try and adjust anything, adjust the speed tomorrow. Keeping in mind it's always difficult to pitch exactly how fast to do things. Yeah. Won't be offended if you put too slow or too fast. It's fine. Just say it's can only be helpful. In fact, it would be weird if it was about right for everyone. That would be that wouldn't make statistical sense somehow. But it would be great. Be anomalous. So if you do need to head off already, thank you very much for your time dedicated today. I know it's difficult to find the time to dedicate to these things, even if you intend to. I know it's going to be quite a slog to maybe sit through and listen to me drone on. Hopefully, trying to keep you engaged. Yeah, that's right, Andrew. Yeah, tomorrow is newer material, hopefully for you as well. So thank you very much for your attention today, and I'll see you again tomorrow morning, same time. The schedule is in the confirmation email. Again, 9:30 in case any concern about the starting time, and on the website. Have a good rest of your afternoon, everyone, and yeah, see you tomorrow.